So, thank you again for joining me. So, we're going to get right into part 3 of event-driven API. So, we're kind of going to pick up where we left off with the previous video and actually take these queues and actually stream them to an event stream. So, we'll be consuming from a RabbitMQ and pumping them to a event stream and displaying it on a simple web page. So let's get into it. Okay, so starting us off, let's go ahead and check out a new repo. We'll be doing part 3, so let's go ahead and get right into that. Check out can't spell and it's part 3 here. Cool. So we'll be doing something a little different in this one. Let's go ahead and set up the web page and see how that works. We're going to be using GoFiber. So straight from their docs, let's go to GoFiber and let's go ahead and we're going to use this framework. This is one of my favorite frameworks for Go. So let's just take that whole code and let's begin our API with that. So let's close this out. Let's also close this. Let's create a new file here, and we're gonna actually no, we don't want it there, we want it here. So let's do this is actually going to be the API, so we'll say event driven API main.go. all right, it's in the wrong place. Let's throw it under here. Yes, let's move it. Okay, so let's just paste in all this code here and see what that does for us. If you see we get the red squigglies, that's because we need to install GoFiber. So let's go get GoFiber. Yeah, whatever. So with that being done, let's go ahead and save that, see what happens. Alright, everything turned green, so we look good. So let's run that and see what we get here. EDA main.go. So we're running on port 3000. So it's, if you're on Windows 11, you might get this pop up here saying it's a security because it's a new app. So let's just do localhost 3000 and see what we get. Hello world. Perfect. So now let's take that to a new file and create a helper function around that. So let's create a new module. Let's call it API server, because like I said, in the grand scheme of things, we're gonna do event driven API. So that didn't go as planned there. Let's delete that, and then let's also delete that, and we'll just add a new file here, API server. Perfect. And this is going to be the package name will be API server, right? So truly, let's just take the code that we have here and move it over there. Here. Alright, so we'll say create API server. And just to see that, so now we wouldn't need these modules here. And also, you know, I actually like using charm bracelet. You guys tell me down in the comments what log module you like using for Go. I like, personally, I kind of like the charm bracelet charm bracelet log and Go. So right here, let's do that. Let's go ahead and close that out. Let's paste that in. So instead of logging here, let's use charm bracelet. Okay, so instead of this, we can kind of clean this up now, because at first we were running it like this. I'm sorry, at first we were running it like this in our main, and now we kind of created a helper function here with create app server. So we don't want to actually execute this here, so let's go ahead and delete the log out of here, and we actually want to return this fiber app that's returned when you call new. So let's go ahead and return that. So let's do fiber.app, right? And let's get rid of this line, because we won't actually want to run it over here. We actually want to run that back in main. So let's take that back in main here, and like we have it here, but instead of fiber new, let's do API server dot create. What do we name it? Create API server. All right, so let's just see based off of that if we get the same functionality. So let's go just so we can validate there. Hello world. Let's do API server here. Save that. Go here, save that one, and let's run that again. Let's go to Chrome. We get this pop up again. Actually, if you compile it first and then run it, you won't get that error, and maybe we'll do it at the end of this video, but let's see for right now. Let's just rerun this. Boom, we get API server. That's fantastic. All right, so what we've done is we kind of created an API server helper function just to help us get a web page going. Simple hello world application. All right, so let's continue in this tutorial. So the next phase we kind of want to do is now we want to actually be able to take some data from a channel or a RabbitMQ queue and then source it for an event stream to the web page. So next, let's actually again let's leverage that fiber framework here, and let's see what they got for. They have an example with SSE, right? So let's kind of just take their SSE example. Server side events, let's close that. We don't need that. Close that. All right, so they have this one here, go fiber recipes.git. So let's just look at that on GitHub and look at the main.go. So here it is. So there's a index, so that's some HTML code to create a web page and then streaming it out to the web page. Here's the app get. This is the index page. This is what's going to render that index page, and then here's the part for the SSE. So let's actually take this section here for the SSE, and it has a path or endpoint of SSE. Let's just take that and put that in our code right here. Let's just paste that in, see what we get there, right? So for right now, let's go full screen with this. So here we go. So if we look through this code, these are the headers to send an event stream. We keep the connection alive, and the encoding is chunks. So event stream is kind of, if you use ChatGPT, how it streams the responses back, so you're not sitting there waiting for it to build an entire response. It streams it back word for word. Event stream is how that's possible. So let's implement this real quick. So it says we need fast HTTP, and I believe that was here in here. So it's provided by this package here, or this module. So let's just copy that out, right? So it's looking for FMT, and I've seen a reference to time. Not sure if we're going to use it, but let's just check it out. So in this example, all they're doing is taking messages from, looks like, an array and sending that out to a stream. But we want to actually take a message from a queue and send it out to a stream. So in this example, we probably won't use much of this. We'll use some of the boilerplate. So okay, so let's do this. All right, so let's make a few modifications. So we know we want to receive data from a stream, so from a channel. So create server, let's let it take the actual RabbitMQ events, and they're gonna come across in a channel that's a stream, right? And so for each connection that comes in here, for this particular service and events, we want to kind of track those. So let's create something to keep track of those connections coming in. So let's just do a simple integer. So let's just do connection count. We just use a counter, right? And just when a new connection comes in, we'll just increment the counter. And then also let's kind of keep all those server send events clients in a list, because we're going to create a channel for each one of them. And so we kind of need a way to keep track of those. So we'll use that connection ID there. So it's that int64, and we'll create another channel that's a type of string. And so for every connection that comes in, we'll create a channel and add it to this map of current SSE clients. Now, another thing we want to do is let's create a quick anonymous Go routine that takes the events that's coming in from RabbitMQ and just send them to all the channels that's created or that we add into this current SSE. So this is a very simple Go routine, and all it's going to do is for every string we get from RabbitMQ, so let's just call it RabbitStream, right? And we're just going to range over those RabbitMQ events. And so we will actually have the string that's pumped into RabbitMQ or from RabbitMQ queue right here. So then we want to iterate through this map of clients and send it to whoever's connected. So another for loop, and we can actually get the connection ID, which will be the integer that we assign every user that hits this SSE handler here. And inside of that, it will be the SSE channel, right? The channel for each one of those clients. So let's range through that current SSE clients, and all we want to do is into each channel we want to pump in what we got from RabbitMQ. So that's pretty simple. All we're going to do is say for the SE channel, pump that rabbit string in there. So this rabbit string is again the data coming from the queue in RabbitMQ. And just for a little logging here, and like I said, we want to use this charm bracelet. Let's add a little logging so we can kind of keep track of that. So right here, when we send it, let's just write a quick log message just saying info, and we'll say something like sending SSE to connection ID, and we'll just list the connection ID. And so we have that right here, right? And so that's it for that simple Go routine. Oh, we need to run it here, so we'll do that. So now we have this connection count. So now, like I said, anybody that hits this SSE, we kind of want to create a channel for them. So let's go ahead and create a channel. So this is the client's channel, which we're gonna add up here to this current SSE clients, but we have to create it first. So this is going to be a simple channel that takes a string in, right? And then also let's get a connection ID for this guy, and all this connection ID will just take the current connection count which we created up here, right, which starting out to be 0. We'll take that and we'll just add a 1 to it, and that's going to be this client's ID. So then let's add this client's channel using that my connection ID right there into that current SSE, right? So when the client comes in, we create a channel and then we add it to that map. Now, before we forget, let's go ahead and increment the counter. Boom, as soon as they get connected. And then we're gonna have a user disconnected Boolean that we're gonna set to true. And you'll see how we're gonna use that in a second. So one last thing, let's go ahead and log that we have a new client connected. So once someone hits this, we'll just say client, let's go back and say new client connected to server-side events, right? And then let's just print out that ID again. My connection ID. Perfect. All right. So everything looks good so far. So again, like I said, we have a lot of things here, but the only thing I think we're gonna actually use is this print and the flush for the most part. Okay. So let's get into it. So again, when someone connects, we just kind of want to run any data that we receive from this RabbitMQ event will be pumped into this client's channel. So we can just iterate over that channel as long as it's open and send the data. So we can just do something like take that event stream, whatever that is coming from RabbitMQ, we can just range over that because we're going to get it from the actual channel that we created for this particular client. And so we'll have that data right here. So from that, let's just go ahead and send that to the browser. Let's event stream that out. Oh, we forgot our I++. So it's part of the data structure for event streams. As you send events, you kind of increment a counter here. And so in order to do that, we need this I variable here that we'll create initially, and we'll initialize it as an int, and we'll increment it for every message that we send. So like I told you, we we're probably only gonna want to take this line here, and this is the line that actually is gonna write. See, so it's data in the message, and that's what we're gonna send to the client. So here is the event string, so let's just put that there. That will be the message we actually send to the client. So once we write that to the buffer, right, we need to flush it. So flushing it is what happens, or it's the event that triggers the underlying network connection to send whatever's in the buffer to the client. So whenever you write something into the buffer, it's just sitting in the buffer on this machine, on the server. So once you hit flush, it actually sends it across the network to the client. And we actually can get an error there. And so let's log if we get an error. Because we're an event handler, we don't want to crash the program because it's only specific to a client. So we just want to log that out there. There was a error while flushing to the client, right? And then this also will trigger it to close the connection. So we want to tell right in the log we're closing the connection. Alright, and then put the error message there. Okay, so then we're going to put error dot error, and I don't know how we got the pointer for that, but let's remove that. Okay, so you remember this user disconnected is set to true. Well, if the server disconnects, the user didn't. So I want to actually change that to false, right? And so that'll let us know if the user disconnected or if there was an error and then it disconnected. So inside that error, we also need to break the loop. So break out the for loop here that we have going here. And at the end we return nil. So if we break out this for loop, that means the connection is closing. So let's log that. So but we want to use that user disconnected. So if the user disconnected, I just want to log the info that the user disconnected user, and we'll put has disconnected. From EventStream, and then we'll just put the my connection ID, and then else this one we'll put a warning here because we'll say the system disconnected the user, and we'll put the connection ID there, right? And also in either case, right, we need to remove it out that map, right? So let's go ahead and delete out of the current SSE clients my connection ID. So like I said, once let's do this first. Let's close the for loop here. Let me explain this. So then, all right, so once the user is disconnected, meaning they've broken out this for loop, or if this channel gets closed, you're gonna break out this for loop. So we want to log out just to have some declarative logging messages that hey, the user's gone, but we also want to remove them from this current SSE map so that as we're iterating over events coming in, we don't cause errors or issues with this piece of code trying to pump in a new string into the channel for that user when the connection is gone. Or we can have a memory leak just filling up a channel that no longer can accept any data. Also, talking through it, I totally forgot, we need to close our channel. Because also, if we don't and we actually continue this loop, if no one's listening to a channel, the channel will block because we created an unbuffered channel. If we would have sat here and put a 10 here, that would create a buffered channel that can hold 10 values of string or whatever you put here. But if you don't declare a value after this, it's an unbuffered channel. So this line of code would actually block until there is something listening to that channel. So again, once the user disconnects, we want to delete it out that map so it's not iterating over it. And also we want to close the channel so no data will so it won't hold any connections or block any code thus far. Okay, so let's go ahead and save that. Let's see what else. Okay, so we initially had a hello world example, right, where we just were sending out where we were just sending out just standard string saying hello world API server, but we actually want to put a website there, right? We want to put some HTML so that the user sees something kind of, we're gonna say just some kind of format that they can see what's going on. So I kind of prepared a simple HTML document for this, but we want to send that to the user, and we're going to use the embed function built into Go to do that. So before we do that, let's actually include that in our program here. So let's create a folder that's gonna hold our data. So we just want to create something called a folder called static and put an index.html page in there, right? And so like I said, I already prepared this, so let's just copy this and throw it in here, right? And just to go through it real quick, it's nothing. It's using Tailwind for styling. It's a simple box that shows the stream events. Again, more Tailwind styling. The only part that you would probably even care about is the event source. It's /SSE, which matches our server because we're going to be listening on SSE. And it's a relative path, so it's from wherever we connect. It could be HTTPS, it could be over port 5050, port 7000, but it's relative. We're just gonna go to /SSE. Very basic there. And again, I'll include this in a Git code repository down in the description. Just comment, like, and subscribe. So let's close that out. That's finished. But in order to use the embed, things have to be in the in the root folder here. So let's create a file here that's gonna get us a new module, and we just gonna call it assets, right? Let's just do that. Real basic Go file, and all this is, we're leveraging that just to do embedding. So we're gonna make it called in a package called assets. We're gonna use the embed module from Go, and all we're gonna do is embed that static folder. Anything in static folder, we want to set it to a variable called static fs and use embed fs file system for that. And again, all this code is doing is if you want code, actually any static file, like in this case index.html, if you want that actually embedded to your Go program when it compiles, embed makes that possible. It takes whatever files by this directive here, static, which is anything in this static folder, and we'll actually compile it into the binary. But not only does it do that, it also gives you access to a variable with that content. So now we have this variable called static fs that now we can go and use it in our API server to read the files from that particular location and then display them as a web page. So let's go back and tie all that together again. This is the magic right here. Anything in the static folder becomes available in the static fs. Let me just reference it like another file, a variable. So if we go back over here, now we can say we want to access that file. So here we'll go to our assets. Now it's a module, and we want to use that static fs variable, and we want to just say read the file. And what file do we want to read? We want to read in there is called static index.html, right? And if there's an error, we just want to return a 500 error to the user. Saying that file is not there. But if it is there, we want to set the header type to HTML, and we just want to send that to the client, right? So I'm gonna send that file, the data within that file, to the server. Cool. All right, so let's go back here, and if you see now, it's expecting us to pass in the RabbitMQ string channel. So just for a quick test, before we marry all that up, let's just make sure what we have so far works. So let's just create a local channel here, and it's just going to be of type channel string, real basic. And then create a go routine just to fill that channel with data. So we'll just say let's just fill it with the time. So let's just say LC. Well, we want to into LC. We just want to create a format spread. Let's just send the time. And then say a string, and then say new event. Doesn't matter. And like I said, let's just send the time. So time now dot format time dot RFC 3339, and then let's just sleep for a period of time here. Let's say every 1.5 seconds, right? So right, to send that event again, we need to execute that. Now let's just pass the LC into the app, again running on port 3000. Let's close that or stop that, and let's execute this and see. We want to type channel string, and we have nothing. Interesting. Oh, look, we didn't save it. Let's just run it again. Allow it. Let's go here to our 3000, just refresh the page. Look, so now we have the EventStream bots. We're connected. However, we're not seeing any events. Let's see. Let's just, how long are we waiting between the events? Okay, hold on. New client connected. So every 1500 milliseconds. So every 1.5 seconds, we should be getting the event. We're not. So let's do a quick debug. So I'm sure it exists somewhere in this API server. So here, all we do is create a string, and we put it inside of our channel string every 1.5 seconds. That's fairly straightforward, and we send that over to API server. So an API server actually receives that RabbitMQ events, iterates over that, and then actually puts that in any channel that's there for a client. So we should see sending SSE events. So we don't see that. So then we create a client channel here, we add it in, and then we send that, whatever we get there, we create a string, and we kind of iterate over that forever. I actually don't see any problem with this code, so maybe let's look under the hood of this and see if we actually connect it to our server-side event handler, or if we got any errors. Let's just refresh the page. We connect to SSE events, so a little live debugging here. So we connected, but we're not seeing any server send events. So let's close that out. This might actually be in the code. Let's see. So we connect to SSE. We send our writer. We print that to our writer, which we got from this buffer IO write. We flush it. There's an error, we disconnect. If not, we sit back up here until we receive something in our channel. That all looks good. When a user connects, we created the channel. Interesting. Here we have a channel, and to be honest, we make the channel and then we initially start pushing data into it. Okay guys, I feel like a complete idiot. So the problem was right here. So I can actually delete. I put in a few helpers here and realize, let's make this 1500. Guys, we didn't even do a for loop here. So it was only sending the one event. And because as we want to test this, we want to send multiple events, right? So let me go back, let me clean up some of my test code I put in here, right? And the other thing was I added this. So let's quit this, let's rerun it. And then let's go to our browser. And so now we're getting new events. So we can actually open up, let's see. Let's open up Firefox here. And let's go to localhost 3000. And so now we have the new event streaming there too. Same time, 1522, 1525, right? So we're getting our events as we expect. So that's cool, right? So now let's actually get it. And so we have our log messages here. Let's see what happens. Let's close this down. And now we got our nice system disconnected here, which is not true. It actually was the user that disconnected, but we'll handle that in a second. Actually no, that's a problem. That's not. Yeah, so that's actually okay. We'll address that in the next video, the difference between the system disconnected, the user. But in all actuality, we can say that for later. So let's go ahead and stop this program here. Wait a minute. Okay, and now let's actually marry that up to a queue. So instead of doing this was like our little demo function where we was just trying to send data in, but in actuality we wanted whatever went into RabbitMQ to actually go out and be published to the event stream on the website. So to to do that, let's just modify this consume here and create a helper around that. So let's just truly copy the whole thing and say consume. Instead of consume, let's say consumer SQ, consumer S channel, right? And this is going to return a channel of type string. That's all. So pretty much we can just go right here and say message channel is equal to make a channel of type string, right? And right here we just want to put that, anything that comes in here, we just want to add that as a string because it's an array of bytes. We just want to send the body right into this message, and instead of saying waiting for message, we won't be waiting no longer. We just want to return that channel, and that's it. But let's create a helper function. So right here, instead of consume Q, we're gonna say get Q as channel, right? And all you have to do is pass it the channel name, and let's get a channel of type string back. And so the only thing we're gonna do is use our new function here, which is consumer as a channel, and we're gonna get the channel there. And whenever this, let's do defer close. So whenever this exits out, we'll just close out that channel. And for right now, just return the channel. So now we have this nifty get Q as channel. So now let's call that. So we'll just name it channel and say get Q as channel. And let's just call this SSE1. We are hard code. Before we were passing that in, we'll just hard code that as SSE1, and I'll show you why in a second. So if all that looks good, let's save it, and let's actually start that back. Alright, we look good here. So it just scrolled down. Let's just refresh the page, and if you refresh the page, you'll see we actually don't have any event streams. That's because nothing's in that queue. So how about we go back to our nifty command line utility that we created called send. It was main.go, and you could just put in from the last video. If you didn't see that video, link down in the description, check it out. All we have to do is put that same queue that we're hard coding and then a message, so we can say hello YouTube instead of moto, and send. Oh, we didn't put our run here, so we say hello YouTube, and that didn't work as planned. You guys probably picked this up too. Is what happened is, as soon as we exit out of this, we deferred that channel close. So we're actually closing the channel before we can receive anything on it. So let's comment that out, right? And then let's actually go let's make this a capital C so it's exposed outside. So in Go, anything that's public is exposed with with caps. Really can't do this here. Come on. So let's expose that close function. Alright, and make it public. Right, and let's save that. And instead of deferring that there, let's go to our main. And if we get out of that, let's close the channel here. You need to expose that. Let's have it return that. Okay, so over in RMQ, for sake of brevity, let's not worry about closing the channel. But no, let's continue. So we need to get this RabbitMQ struct out. So what I think we're gonna do is we're gonna do both. Let's return both. Let's return the RabbitMQ and the channel, and so that way we can actually just close it out in our program here. So here we don't just get the channel, we get RabbitMQ, and then once we pass this, that's a fatal. Let's just make that an error. We'll just log that as an error, and then we'll say r.close. So once we get out the API server, whether we control C or any kind of way that we exit the app or the web app, we'll hit this close, and this will terminate the RabbitMQ session. So again, let's try that out. Okay, we can allow that. Alright, so we got one connection there. Let's go over here and say hello YouTube 1. And look what we got here. Hello YouTube 1. And I know, guys, this video was long. My apologies, but I wanted to show you a little live debugging and also how we can get server send events from a RabbitMQ. So if you guys like this content, please like, share, subscribe, smash that notification button. Trying to drop videos for coding in Go. I'll also create this example in Python. If you guys just let me know down in the comments if you would like to see this done in Python, I can do that as well. Alright, anyway, you guys have a blessed day. Thank you for watching.